What if a robot could actually outrun the fastest person alive?
The big winner of the competition was China's own Unitree.
Just imagine it, a machine tearing down a track at a speed your eyes can barely track. And here's what's wild, this has already happened. While most of the world is still figuring out how to make robots walk without toppling over, China has been quietly building machines that sprint like apex predators and think like supercomputers.
So we are going to spend 24 hours doing as much stuff as we can, pushing this thing to the limits and see what it can really do.
We're talking about four-legged robots that launch off the line like electric bikes, and two-legged humanoids pulling off full 360-degree spins while running at top speed.
The Unitree H1 is extremely fast and highly advanced in balance and movement.
China is producing the fastest legged machines the world has ever seen. And in this video, I'm breaking down the 8 fastest robots to come out of China, including one that shattered every robotic speed record in existence. Let's kick things off with a robot that proves cutting-edge technology doesn't have to cost a fortune. Standing just 1.27 meters tall with a starting price of around $16,000.
Now they do say that the starting price is $16,000, but all in all, it is still one of the cheapest humanoid robots on the market.
The Unitree G1 seems pretty unassuming, almost like a small lab assistant designed for universities and research centers. But once this thing starts moving, you realize it's something else entirely. With up to 43 degrees of freedom, the G1 moves with a fluidity that feels impossible for a robot in this price range. Its legs pump with sharp mechanical rhythm. Its upper body shifts to maintain balance like a seasoned runner, and its hands stay remarkably steady even at speed. No humanoid this affordable has ever demonstrated this kind of stable locomotion. Suddenly, high-performance robotics isn't just reserved for billion-dollar labs anymore. It's available to anyone willing to push the boundaries. But here's the key. The G1 was never built to be the fastest robot out there. It was built to be the starting point. It's the machine that students, entrepreneurs, and scientists will train on before creating the robots that dominate future speed records. Think of the G1 as the first domino. What follows is an avalanche. Because China isn't just teaching small robots to move, it's engineering machines that are beginning to outperform the human body itself. And the next entry on this list is living proof of that. Picture a humanoid robot barreling toward you with the stride pattern of a competitive sprinter. Sounds like fiction, right? In early 2024, one video changed everything. A full-sized humanoid clocked at 3.3 meters per second, legs driving forward like hydraulic pistons, balance so refined it looked almost human. China had officially built a bipedal robot that could truly run. At 180 centimeters tall and just 47 kilograms, the H1 is built like a lightweight athlete. And it performs like one too. Its leg joints generate a staggering 360 Newton meters of torque, launching it into powerful, ground-eating strides. Its onboard sensors and control systems make corrections in fractions of a second, recalibrating posture, redistributing weight, and fixing balance issues with the reflexes of someone who does parkour for a living. Staircases? No problem. Obstacles in the way? It weaves around them effortlessly. Open ground? It transforms into a full-on mechanical sprinter. And here's something most people don't know. Unitree says the H1's potential top speed exceeds 5 meters per second. That's over 11 miles per hour. Fast enough to outpace most casual joggers. The H1 wasn't just a technological achievement, it was a statement. China has moved past copying what others have done. It's leading, it's pushing forward. But that's how breakthroughs work. The moment one barrier falls, something faster is already waiting behind it. And the next robot showed the world that raw speed means nothing without the endurance and adaptability to handle real-world conditions. Picture a humanoid robot blasting across open desert, sand flying behind it like a distance runner who simply refuses to stop. That's precisely what the robot-era Star 1 was engineered to do. The Star 1 didn't build its reputation on a treadmill or a lab floor. It built it in the brutal heat of the Gobi Desert. In 2024, this bipedal machine ran across the desert near Yumin in Gansu province, sustaining a top speed of 3.6 meters per second over sand, loose gravel, dry grassland, and rocky trails for an astonishing 34 minutes straight. No polished surfaces, no climate-controlled testing environments, just unforgiving terrain and a robot that refused to quit. And then came the moment that broke the internet. Two Star 1 units ran the exact same course, one completely barefoot, the other laced up in sneakers, and the one wearing shoes won.
Robot Era's experiment also showed that robotic humanoids run faster when wearing sneakers than barefoot.
For the first time ever, we had actual evidence that footwear makes robots faster too. But just as everyone thought humanoid running had hit its ceiling, China dropped something that took that speed to an entirely different level. How would you react if a full-sized humanoid suddenly exploded into motion with the speed and poise of a professional athlete? That's exactly the kind of shock the Robot Era L7 delivered when it first appeared.
So here's our flagship humanoid robots. The code is L7. So you can see that it's a full-size bipedal humanoid.
At 171 centimeters tall, with a remarkable 55 degrees of freedom, the L7 is the closest any Chinese company has come to building a humanoid that both moves like a person and performs like an elite athlete. It reaches 4.0 meters per second with a fluid, assured stride, driven by 400 Newton-meter joints that unleash explosive power for spinning, twisting, leaping, or even full breakdancing routines that look almost choreographed. But the speed is just one part of the equation. The L7 can hoist 20 kilograms using both arms, hold perfect balance while loaded, and scan its environment through 360-degree multi-sensor fusion, giving it total awareness of every object from every direction. It ranks among the most capable full-size humanoids on the planet, not just within China, but globally. Now, if the L7 is the ultimate showman, the next machine is a completely different beast, designed not for flashy moves, but for brute industrial power combined with unexpected speed. Imagine this, a robot designed to haul heavy loads suddenly breaks into a dead sprint, and it's not laboring, not decelerating, but powering forward with the momentum of a small vehicle. That's the Unitree B2. This robot was never intended to be a racer, and yet it outruns nearly everything in its class. It hits 6 meters per second while lugging over 40 kilograms, with a maximum standing load capacity of 120 kilograms, a blend of raw strength and pure speed that no other commercial quadruped on the market can touch. Its 360 Newton-meter joint torque allows it to accelerate while loaded, conquer staircases with confidence, and stay perfectly balanced even when the ground beneath it changes without warning. The B2 is the robot you deploy to the places humans avoid: collapsed mines, active disaster zones, industrial facilities, sprawling warehouses, active construction sites, and it arrives faster than most people could on foot. It's a workhorse, wearing a sprinter's shoes, a machine that completely redefines what we expect from industrial robotics. But if the B2 demonstrates that strength and speed aren't mutually exclusive, the next robot reveals what happens when you push speed past what legs alone can deliver, into a realm of motion that feels genuinely superhuman. There's a point where you're watching the Astrobot S1 operate, and your brain genuinely struggles to decide whether you're looking at engineering or sorcery. This robot never takes a single step, yet when it comes to reaction speed, it leaves nearly every other machine in the dust. The Astrobot S1's arms move at 10 meters per second, fast enough to rip a tablecloth out from beneath a tower of wine glasses without a single one budging. Fast enough to chop vegetables in midair, cook with impeccable timing, produce detailed calligraphy, or handle factory floor tasks with a response time that no human nervous system could ever replicate. Each arm supports a 10-kilogram payload while still moving with surgical precision, a pairing so unusual that even top-tier industrial robots have trouble matching this balance between velocity and delicacy. The S1 is proof that speed isn't always about locomotion. Sometimes the fastest robot in the building never moves its feet. It just whips its arms at velocities humans simply can't achieve. And while the S1 rules the domain of reaction speed, the next machine commands the arena everyone instantly understands: all-out sprinting. What would you call a robot that runs so fluidly you genuinely can't tell if it's a machine or a living predator? That's Black Panther 2.0. At just 38 kilograms and standing 0.63 meters tall, this compact quadruped holds the record as the fastest, untethered four-legged robot ever built, crossing 100 meters in under 10 seconds with a peak velocity of 10.4 meters per second, a pace that puts it neck and neck with Olympic-level sprinters. Watching it move is eerie in the best way. Its legs slam the ground with ferocious accuracy. Its body autocorrects mid-stride, and its rhythm mirrors that of a living creature hardwired for pursuit. That uncanny realism stems from design pulled straight from the animal kingdom. Jerboa-inspired carbon fiber legs offering 135% greater stiffness for explosive rebounds. Spring-loaded knee joints that soak up impact the way animal tendons do. Cheetah-modeled running shoes that boost traction by 200%, and an AI-driven gait system built on the Huygens pendulum principle, synchronizing every limb like a coordinated pack hunter. What you get is a robot that doesn't just run quickly, it launches, pivots, and surges ahead like a creature forged through millions of years of natural selection. Put simply, Black Panther 2.0 isn't attempting to copy an animal, it's trying to beat them. And incredibly, there's still one robot that makes even this. Mechanical Predator looks slow, a machine so fast it erases the boundary between running and rolling. We've arrived at the undisputed champion of versatile speed, the Unitree B2W. 1 second it's walking on precise, articulated legs. The next, those legs lock into wheel mode, and the robot rockets forward like a motorized vehicle, topping out at 20 kilometers per hour. It hauls over 40 kilograms, holds its balance at velocities that would cripple most robots, and switches between legged and wheeled locomotion with a fluidity that looks almost organic. Every stride, every wheel rotation, every burst of acceleration is governed by high-speed actuators and intelligent algorithms built for a single purpose: merge the rough terrain agility of legs with the flat ground efficiency of wheels, and outclass anything restricted to just one mode. This isn't just about being fast, it's a preview of what mobility will look like in the future. Machines that don't just keep pace with industrial demands, but dominate every type of terrain thrown at them. And that's why the Unitree B2W earns the top spot. No other robot on Earth fuses this degree of agility, balance, endurance, and terrain adaptability into a single platform. And right now, nothing else even comes close. So which of these speed machines impressed you the most? The desert-conquering humanoid, the record-breaking predator, or the hybrid beast that moves on both legs and wheels? Let me know in the comments. Do you see this as pure innovation, or does it feel a little intimidating?